All right, hello there. My name is Sean. I'm kind of making this video as a way to try out a new study method. Probably won't work, but yeah, I might share this with some people. So if you're not me from the future, then yeah, hello. So let's just jump right into it. So the first thing that we need to know for the test, it seems, according to this list, is data types. So all right, so Java is statically typed, which means that you have to name the type of every variable you put in. So like whenever you name something, you said like int a equals 2. So either type, the name equals something. And yeah, this is kind of how it all goes. Like when you have like a class, person or something, you'd say like person Sean equals, new person, blah, blah. Right? All right. So let's see. So these are the primitive types. These kind of store like little things that don't take up much memory. So they can actually live in the stack, which we will get to. But yeah, these are the different types. To remember all of them, just say int, byte, short, long, double float, char, boolean. Say it to yourself like over and over and over again, you'll get it. So let's see, an integer is like, let's see, that's like the, so let me pull up the ranges on these. So yeah, the smallest one's going to be your byte because it's going to be from negative 128 to 127, which makes sense because it's eight bits in a byte, and you can store up to 128 times 2. So there you go. And the next one's going to be the short. That's like up to, let's see, about 32,000 or so. Integer gets a little bit longer. And then let's see what after that. I have the order right here. Yeah, so yeah, byte's the smallest, and then short's a little bit bigger. Int bigger, then long is like really really big numbers. And usually put this little L after it, I believe. And then float and double are the decimal things, and a float is less precise than a double. And you usually have to put this little f here because Java will see this as a double. And when you try, if I just put this in here, I get an error because oh, and I'm gonna run them in the command line. Don't freak out about that. But whoops. Let's see. This is test review. Yeah, see, I get a little error here saying that I can't convert from double to float. So you got to put this little F right there, and then it should run fine. Yeah. So let's see. Um, let's see. And then the last two. Go away. Let's see. The last two are going to be your char and boolean. Char just takes one character. If you put more in there, then you're going to get an error because that's not a character. Makes sense. And then boolean, just true or false. Yeah, so when you convert between data types, you can't convert to where you lose data, like where we see where if you just did this, you can't do a double to a float. So you have to go. So if you're going to convert, you're going to have to convert from these types over to these types. Like, let's see, if you do like a byte equals. Actually, hold on, I need to make sure I get this. I got it. So you have to convert from these ones over to the bigger ones, the more precise ones. So like if I have an integer and I convert it to a long, that's totally fine. That'll run. As you can see, it's just code that's coming up later. Don't worry about that. Close out. But if I try to convert from a long this way over to a short, it's not going to work because I'm going to get an error for that. That's going to be a lossy conversion right there. So So then you have the non-primitive types, which are going to be like your strings, your arrays, and any other object that you come up with. And the difference between these, I believe, are the primitive types, their value and their name are actually going to live in our stack, which, if you remember, was that diagram he drew on the board. So yeah, they're both the name and the value going to live in the stack, but for like a string, it's this is like a lot of data here, so we gotta throw this over in the heap, and then we just keep this little name over here in the stack. But for the int, both this name and this value are going to be in the stack. Let's see. Another thing, strings are immutable, which means that once you don't worry about this code, but like once you make a string, like if you change it, this string is going to stay in memory. It's going to make a new string from like say you made like this plus say you have this string and then you put like AA plus equals AA plus GGG or something. It's gonna make a new string called like string that instead of keep just adding on to this one. All right, so the next thing up is the control flow, if else, and loops. So these are pretty similar to Python, so don't worry about these too much. So let's see, for loop, you always gotta say for. Remember to always declare this variable. I always forget that. So you say for int I equals 0, and then I is, if you use less than here, so less than equals, whatever this number is how many times it's gonna run. And then you have to increment it. So you declare a number equals 0, less than something, however many times you want to run, then increment it. And you do that stuff with the index I. So like it's gonna become 2 the next time, 3 the next time. You can index through stuff or something like that. And then this is called a for each loop. It's a little bit different. Instead of being an index where you're gonna index a string or something and it's gonna increment each time, this I is going to be the value of something. Like in this case, it's kind of like saying for int I in this array. So each time it runs, the I is going to be 1, 2, 3, but I can also make it like this, and it's going to be 44 that time it runs. It's going to be whatever it's in the array. So then let's see, look at these if, else, and switch statements. So it's pretty similar. Just if, put the condition in parentheses, and remember the brackets. Else if, remember it's two separate words in Java. It's going to be a condition there. Else, yeah, default thing, you know that. Then there's a switch statement. The syntax is a little hard to remember, but see, so you do switch and then in parentheses put, oh, that should actually be the variable there, I believe. Make sure I don't get a compile error. Whoops, still didn't erase from last time. This thing up here, yes. It should be fine. So you put switch and then whatever variable you are taking a look at. And then you put these cases here, and this is what's going to happen if this thing happens to be this value or this value. So switch variable in parentheses and then whole thing in brackets, and the case, whatever the value is with a colon, and then your stuff, and then always put the break statement or else it's going to run the default every single time, I believe. So yeah, the default is what happens if it's not any of your cases. So I believe if you don't put this, then you get an error for that. Actually, no. Okay. Just kidding. All right. So then arrays. I think that's the next thing on our list right here. Yeah, it's pretty simple. I kind of like a list. So the old-fashioned, I guess the main way to declare a array is you say a type and then like these little brackets right after it. It's the same thing as putting the brackets here. It doesn't really matter. Then you say is new, whatever the type is with the brackets, and then this is going to be the size of your array. And yeah, and don't worry about like the 0 beginning, whatever. Like it's like if you say 3, it's gonna be 3. And this is the fun way to make an array, the array initializer, where you just say the type, declare it, all that. And you just say equals this. It's kind of like a literal way, I guess, to say an array, and you put the numbers inside these little brackets, and it makes an array of that size. And you can't. If I'm wrong on this, sorry, but I'm pretty sure you can't make an array bigger than how you initially declare it, so careful with that. Okay, and then, so yeah, as I may have said, array lists are the next thing on our list. So let's see. So in order to make this, you say, first you have to import from Java util array list. And you don't need this for arrays, it's just to print them out. I'll show you that in a minute. But let's see. So in order to make an array list, you say array list, and then you put in these brackets what the item, like what type they're going to be. You could also, like if you had like a class of something like person, you can have it as that too. And then this is the type, and then the name equals, and we're initializing it here. So you say new, and then if it's going to be another string, it's going to be another string. Then you always remember to put these little parentheses here because this is a constructor. If you don't do that, it's not gonna be good. So then let's see. When to add an element, you just say list.add, and you remember like don't put something that's not the type in there. Have it as a string. And what's really cool about array lists? Let me pull this up. What's cool about array lists is you can just print them out pretty easily. So see right there, and it formats it pretty nicely. if you try to print an array, yeah, when you try to print out an array, you just make an array and then print it. That's not going to format as nicely as like the array list did over here. So you get this nice format here, but we're going to get like this memory location or whatever. So in order to print it out really nicely, you can use this Java util arrays class here to or package, whatever that is. You can format it nice like this. So you say arrays.toString, whatever your array was, and it'll format like an array list. So yeah. So we already went over the add. You can also add an index. Like if you want to add index 1, you want to place this thing. Then you just do add, whatever your index is, comma, second argument would be whatever you're adding. And then for removing elements, so you just say, obviously remove. And it's only going to remove 1, and I believe it's going to remove the first one. Yeah, so like see, we have 2 hellos up here. And so we removed hello. What it's going to do is it's going to remove the first hello from there. So you have 2 hellos here, and then it's going to remove one of those. How do we loop through these like arrays? So if you want to loop through with an index, what you can do is, first of all, arrays and array lists are different because an array will have a like array. Make sure I'm doing this right. Just see if I go up to this array and say x.length with no parentheses, that should give me a good value. Yeah, see, that's fine. But for an array list, it's going to be size with 2 parentheses. Don't forget that. Okay, so if you're going to loop through with the index, you're going to use the get method here, and it's kind of like index an array, like it would be like x I or whatever. But yeah. And then you can also use a for each loop, obviously, where you just go through whatever thing whatever thing is at that index, or yeah, is going to be the thing you're going to work with. So we have methods for finding stuff in the array list. So index of is going to return the first instance of whatever it finds, and then last index of is going to search from the right side instead. If you look for index of and it's not in there, you're going to get a -1. Kind of like in Python with, I think it was find. And then you can also look if it contains. This is super useful, as you probably learned in the library assignment. It's if it doesn't contain it, then it's gonna be false. If it does, then it'll be true. So there's a thing called a multi-dimensional array list, an array, and this is basically an array of arrays. And you can think of the indexing as being, so this first one is going to be whatever array, like, okay, so you have an array of an arrays, right? And let me see if I can make this visually. This is not proper syntax, don't need to do this, but just to show. So this first one is going to pick the row, which is going to be like which array in the array list, and the index is going to be which one of that. So if you say like 0, 1, then it's going to go 0, and 1 right there. So in order to make this, you say int with 2 brackets, and then you say equals new int with 2 brackets, and how many arrays you want and what the size of each of those arrays are going to be. I was wrong. This actually is proper syntax for this. This is how you use an initializer for multiple arrays. And so if you do it like this, then you're going to have let's see, if you say, go back, if you say like 2, 3, you're going to have 2 arrays and each is going to be size 3. But if you want to make them different, you could use it this way. And so this one has size of, or length of 5, and then this is 1, and it's 6. So remember that's, let's see, so 0, 0 would be 0, 0, and 1, 0 would be 1, 0. So, okay. So yeah, if you want to make a multi-dimensional array list, then you make an array list of type undetermined type array list. So array list, instead of string here, you're putting array list of unknown type, whatever your name is, and then new array list of unknown type. Don't forget the parentheses. And so then you can like make an array list here and add some stuff to it. And then you can actually add the array list to the array list of array list. And then if you want to get something from this one, you can use like get. You can use get at this index, and then that dot get whatever index you want here. And that looks like I forgot to mention set if you want to change the value of something in there. Like there, you set the first value and double this to this thing. So make sure I didn't forget anything with array list. So this is a review. These are on line, by the way. I'll show you in a second. But let's see. To make an array list, you do array list, then your type, your name, and then new initializer. To add stuff, you do that. This is indexing. That's returning the size. Remember, it's size instead of length. And then if you want to add an index, you can do that. You can just print an array list. And this lady keeps like talking. It's weird. And then let's see. Yeah, array list actually has a copy constructor, so you can, if you want to make a copy of array list X, like a hard copy, I believe, you just put it in those parentheses right there that you normally leave empty, and it will make a copy. Oh, and don't forget the wrapper classes. So you can't actually make an array list of a primitive type, except actually, I want to say short on this list, but I'll have to look that up. But remember, you put the capital letter there, so instead of you can't make an array list of int, you have to use integer, all caps, and then bytes the same with character instead of char. So I guess you would just always write the word and put a capital letter. This is how you remove something. You try the index of it. If you want to look from the other side, returns -1 if you don't find it. Yeah, it looks good. So next up on our list is all about classes. So what the heck is a class? So I kind of think of classes as like a little file that you just put stuff in. It's really defining like a data type, sort of. So if you had like, say like, person here, then they would have like a name and like things that people do. But I'm just going to show you the basic. Basically, like you can think of them as like just files that you're putting stuff in. So in order to actually run like something, you have to have a main loop, or main method, sorry. And yeah, if you run that, nothing's going to happen. If you don't have that, you'll get an error. So then, so what I'm going to do is I'm going to make stuff in the class 2 here, and then I'm going to run it in class 1. It's just going to be like my little test class. So first we have, let's say it says instance variables. So this is a variable that an object of this class is going to have. So let's say, let's see, so you declare them as private usually. The reason for that is you don't want future programmers changing up these instance variables up here. You want them to use your methods to do that. So let's say private x equals 5. Oh, you have to declare it. Don't forget that. I am terrible at that. And then let's say, private string y equals hello. Cool. Now if we're going to define a method, so we want people to be able to use your methods. So usually those are going to be public, which means you can access them from other classes, like our test class right here. So let's make a constructor first, which is going to happen whenever you initialize something, like when we made like a new array list, for instance. So the way you do that is say public, and then let's see. Yeah, I just forgot for a second if we should capitalize this, but let's see. So it's going to be public, and then your class name, and then whatever parameters you want them to put in with that, and then so let's say whenever you make one of these classes, let's say it prints out hello. I think this will work. Okay, look at this. I made a class 2 type thing called goat. So type and then the name equals, and then this is the initializer right here. And so inside the initializer, when someone runs this, it's supposed to print out a message. So let's see if it did that. So I'm running class 1 right here, and I don't know why it's taking so long. Oh, there we go. And yeah, print out this little message. So I ran that constructor. Cool. So remember we hold on one second. So remember we talked about overloading the constructor. And so what that is making multiple constructors. They're named exactly the same. Which you can do in Java. You can name different methods as long as they have. You can name different methods the same thing as long as they have different inputs, right? And so this is so these are providing you with different constructors. So right here I made a class 2 type thing called goat, and I didn't pass anything into there, and that worked. So it's gonna run this, just gonna print out this little message, and then so this time I actually passed in 2 values that are I kind of put as are gonna set this. This is pretty common where you pass in what the instance variable is going to be. You say this object's x is going to be equal to the x they passed in. This object's y is going to be equal to the y that they passed in. Then I'm going to have a little print this out so that we know it's running. So let's see if that worked. And yeah, it so ran hello, and then it ran the other returner. So cool. So in Java, when we print out a variable, we usually get its value here, which makes sense. So we printed out 5 here, 5. So what if we print out an object that we made? Like I made this fish up here. What if I just print out that fish? So we're actually going to get this weird memory location. So sometimes we don't want people to print this out and get this boring thing. So we can, as we learn, we can override the toString thing. So basically, when you print an object, it's going to run its toString method, which is going to be in the superclass called object. I'll show you real quick. Yeah, and this is this object API. You can see it actually has toString already built in. So every object you make is going to have this method already made, as well as all of these others too. Like when you override the .equals method, it's going to be right there. So when I just print it out like that, it's running that toString method. But if I want to make my own method, I just do it again. And this is with all inheritance. If your class inherits from something, you can just override a method by rewriting it. Oops, I did not put that there. Okay. And so now when I print this out, it's gonna print out goats are amazing. So when I printed fish here, let's see. Oh, crap. Hold on one sec. Yep, I messed up because remember when you define a method in Java, you want to write public or private, and then what it's returning, and then the name. The only time you don't write what it's returning is when it's a constructor. And I got a little confused right here. So now when I print out the fish, it should give goats are amazing, which it does. Cool. All right, so the next thing up on our list is equals. This one is super hard. Okay. So we're going to make a method. We're going to override the equals method from the object class right here, kind of like how we overrided the toString. So it's going to be public, return type is Boolean, and you have to name it equals, and then you're going to pass in a type of just object, which is of this object class. So so the first thing you want to check. So when you make a equals, you want to check. Let's see. So yeah, when you override the equals method, you want to check first if it is the right type. Like, because they could pass anything in here. They could pass an int in here or something. You want your program to just like crash. So so you're just going to check if it's the right type you're looking at. And you're going to check if it's equal by your definition. So what do I mean? So first you're going to check O. So you pass in this object called O. You're going to check if O is an instance of class 2, and that's going to check if it is a class 2 or a person or whatever class this is. And then so if that, then this is the code we're going to run. And then then you're going to make a little temporary object that's going to be of this type by casting this O into that. Basically what you're doing is like so I'm making a type of class 2 called cow, and I just said I want you to take O, I want you to put it in disguise of a class 2 object. So and then so now we're going to check. So now we have a cow that is the same as our O pretty much, except it's now of class 2 type. So now we can use class 2's methods. And I went ahead and I added a little getX method because this is private and we can't access it from anywhere else. So so I'm going to say, so for my definition is if 2 class 2's are the same, if their x's are the same. So I said if cow.getX is the same as this object's x, then we're going to say true, else we return false. And remember, this is a little thing. If you ever put a return in an if statement, you have to do an else return false. And same with this one right here. So this false is going to return false if if x's are not equal, then this one's going to be if it's not a class 2. So actually went ahead and put these little messages in here. So if it's not going to be, if the x's aren't the same, it's going to give us this not equal message, and if it's not a class 2, it's going to give us this one. So how are you like actually using this? So so I'm going to check if this fish class 2 object is going to be equal to this class 2 object and also this one. And I'm going to see if it equals this integer I made here, because this isn't even like of the class. This is an int right there. So let's see. So this one's going to be true because I defined it as they're equal if the x is the same. So this just should be true, and then this one should be false because x is different. This should be false because x is an integer and not a class 2. So all right, so let's run this and see if that's right. So true, false, false. Yeah, so we have true, false, false, and this is because they're not equal. This is because there's not the right type. Cool. The next thing on our list is getters and setters. And I kind of use this a little bit right here when I was talking about the equals method. So basically, you have these private instance variables here. You want people to be able to access them because otherwise, just an object with everything locked down, like how's that useful? So what we're going to do is we're going to provide a way to access these. And usually I do them right underneath these constructors here. I like to make a little divider line thing so that people know that I'm putting them in there. Stanley cover these up. Another term for getters and setters is accessors and mutators. So I'm going to put those labels in there. So basically, what the get methods do is they just return x. So you just say return this dot x. You can also just say return x, but it looks a little nicer when you just say this dot x. And same as this get y, return this as y. Remember, you put the return type as what it's going to be. So this is going to be returning this dot x, which is an int. So you put int there, and it's returning a y. So you put string there. And then mutators are going to be switching these variables to some other value. So let's see. Losing my train of thought. So yeah, so when they run set x, they're obviously going to pass something in, and so you have to declare this here. Remember, so they're going to be passing an int. So and then you're going to say this x is going to be equal to the x that they pass in. You don't have to name it x too. You can name it like pizza or something, and it'll be fine. But and then string y, same. This y is equal to the y they put in. So I guess the major difference is with the accessor method, you don't pass anything in because you're getting it, so you're just going to return that. And for a mutator, you're going to be passing something in, and it's going to be void because you're not going to be returning anything. You're just going to be setting it. Yeah. And, sometimes you can declare something here, like if you want to return a boolean if you was successful or not, or something. I don't know. The next thing up is methods. We've already been working with this anyway, but so we put in public if you want to be public. If you want to be if it's gonna be private here, I guess that would be like a helper method. If you were like gonna call display method message from in here and you don't want people to just be able to call that normally. So yeah, you just say so public or private, and then the return type. Remember, you don't put return type on the constructor, but you do here. Yeah, looks like my recording like messed up or something. I don't know where it cut out. So we're talking about UML here, because that was the next thing on our list. So basically, you have this box where you talk about what's going to be in the class and what it's going to do and stuff. So with the name up here in the first part, and then the second part, you're going to talk about these instance variables, and it's going to be a plus if it's public and a minus if it's private. That's what we learned. And then same with the methods here. And these are going to be the methods that you have in there. And yeah, that's pretty much it, I think. Yeah, and the last one, it says classes using other classes. I mean, we've kind of been doing that. Like when I run stuff in this class, it's literally using stuff in this class. But I could have a class 3 maybe and access stuff from class 3 in this one, or they're all connected. And also you can like have classes inherit stuff from other classes and all that jazz. So yeah, they're all connected and related. All right, the next part, JUnit testing. All right, so next we gotta hop over to Eclipse, unfortunately. Let's see if I can do this on the first try and not pause. So let's see, we're gonna make, yep, hold on. Yeah, I forgot. So you go File, New, and then JUnit test case, I think. And then, yeah, let's see. Now we have this empty JUnit test class thing. And if we run it, then I don't. Okay, good. So we're gonna have this, red one because this told it to fail anyway. So let me just like get rid of that. Yeah. So inside this JUnit test thing, first, up here, gonna import anything you need to import, of course, and then let's see. Inside this thing, it's usually gonna be the name of your class followed by the word test, and then so first you're gonna declare all of the objects you're going to be testing up here. So just put them, naked up here, private, whatever. And then in the at before, so you put at for annotation, and then you make a method called setup, and then inside here, you're gonna actually initialize the objects. So I declared fish here, and then I'm initializing it here with using our constructor over, where was it? Yeah, right here. So then, and then when you test method, like right now I'm testing the getX method. So you're gonna say public void and then test whatever you're testing, and then so you're gonna make some kind of assertion in here, and basically what this is saying throw an error unless these two things are the same. So hold on one second. What I did here is I said, so fish.getX, so that's going to be 3. And I usually put it in a thing called like what it is, so I know what it's supposed to be. And then I say assert equals 3, and then whatever this is. And so then when you run it, you should, if those are equal, you get a green bar. The good thing to do for once in a while is try to throw it off, see if it's paying attention. So 8 should not be equal to 3, so we should get a red bar right here. And yep, we get a red bar. Or at least we get a blue box here. If we get a red box, then see like 0 divided by 0. Okay, we get a red box. That means there's an error or something. But a blue box is good. This means an assertion failed. So yeah, put that back to 3, and it should be good. Yeah. And here I tested our display message method where I print out this thing and I also set x equal to this. So I made sure it was actually setting x equals to this. And so now, so I said if that equals that, then put a green bar, and that's what it did. So what's great about this is if I go in here and I'm like messing around, I change something up, say I like change this to this, then when I go back here, now I can see that, why didn't that work? Oh yeah, sometimes stupid clips. Clips won't update it unless I click on there. It's kind of annoying. But yeah, so see now it's not going to work. But if I go back and I fix that, and I go to here, click on that because it's annoying, and then yeah, we get a green bar. So yeah. So the next thing on our list of fun is sets and maps, which are just like dictionaries in Python. So let's see. I'm going to go over here and. So the difference between a collection like an array list and a set is a set has no duplicates in it. So if you try to add something twice, it's not going to add, it's just going to ignore you. And then so hash set is organized by some kind of categorical order, but if you make a tree set, it's going to be in some kind of a sorted order. So regular, like array lists, the hash maps are going to have a. Wait a minute. Sets and maps. I am getting all over myself. So yeah, first let's talk about sets. Maps are the dictionary things. Okay, so sets. All right, so sets have a size just like an array list. You can also go through them with a for each loop, and yeah, you actually can't index through like you could with arrays, like we did. Oh, I don't even know where the code is, but like. You can't loop through it with an index because index doesn't make sense in a set. So yeah, and there's two types. There's a hash set and a tree set. This tree set has some kind of sorted order. So if your elements can be sorted in some kind of order, then you should use a tree set. If not, just use hash set. Hash set is actually more efficient, I've heard. So that's a good default to use. So just like array list, it has contains. Yeah, the way that you make it is you say, so you have to import a hash set from Java util. And so you say hash set, and then whatever the string is, what you're passing in here is going to be strings. So it's going to be a hash set of strings. We can also put in like a person here or whatever, doesn't matter. And so then name and then new and then the same type there. Make sure to do that. And don't forget to print these because that will throw you for a whirl. All right. And then, so next we're going to move on to hash maps, which are like dictionaries. And see, with this, you're going to have two values they're putting in. So a set, you're saying, okay, I'm going to make a set of strings. So for a hash map, I'm going to have a set of where a map of where the strings are the keys and the strings are also values. So see, when I add something here, which is using the put method, I'm saying, all right, so when someone looks at key in here, I want the thing to be associated to be the string value. So maybe a more better way to look at this would be if I had a map of a string with a long, where like it'd be like a name with a phone number. And no, it's not actually a phone number. And actually, I'd use longs because integers are too small to use for a full phone number. And also, fun fact, you can just put these little underscores in any number and Java just ignores them. So it makes things look nicer. So yeah, then like if I want to get someone's phone number, then if I want to get someone's phone number, I can just say get Sean, and what's going to happen is it's going to print out a phone number. Yeah. And if you don't like someone anymore and you want to remove the phone number, you always use remove to remove that. By the way, in case I do end up sharing this video, all these sets are available on my Quizlet on Escape on there. So cool. So last thing on here is software development lifecycle. I'm actually going to put that on at the end because I haven't actually looked at that yet. And then also test-driven development. There's probably going to be some like conceptual questions on that. So I'll also probably put something on that. So I'm going to take a look at the labs a little bit too, because they said everything in the lab you have to be responsible for. So, so the first one was the Java I/O tutorial, and so this is mainly with streams, scanners, all that stuff. So the way you make a scanner is you import from Java util the scanner, and then so in order to initialize it, I usually use Q for some reason. That's just what I use. So you say scanner Q equals new scanner, and then you put system.in inside here. And so now this is a functioning scanner. So when you want to use it, you can just type in I need to explain this better. In this file up here, I made a scanner called scanner Q with system.in. After making the scanner, you can use it by saying q.next something. So I'm going to say next line. That's going to give me a string. So I'm going to say x is equal to the next whatever the user puts in. Then it's going to print it right back out. So when I run this, it's going to wait for me to type something in. It's going to like sit in here, see? So I can type something in here. It's going to just echo back to me what I wrote. You can also say like next int. I said this will have to be int now, obviously. It's going to put whatever they have into an integer. So if I do this right, yeah, it's going to echo back 3. What if I type in something that's not an integer, like pizza? Yeah, then you're going to get this exception here. So so how do we loop through and also prevent against that? So let's see, I'm going to just get rid of this real quick. Then so inside here, inside this while loop, you can say while q.hasNext, which means while the user is still typing stuff in or typing anything in, I want you to print it out the next line here. So let's try this. So it's gonna wait for me. I can like this stuff in. I'm just gonna keep echoing back whatever I do. But if I type nothing, if it's hit enter, then oh, I guess it's just runs forever. Yeah. If we say has next int or something, then that means that it's only going to run this if there's an integer next. So so then we can say like next int pretty easily because then they can't ever access this line if they type in pizza. So let's try this. So I can type in 3. It's gonna go back 3, 4. There you go. If I type in pizza, then it's gonna stop and it's not gonna run the rest of that. So yeah. You can also do like has next double. This way, whenever it echoes back, it's gonna take whatever I do, put it into a double. Or if I say a letter and it's not gonna work. Even like has next boolean. So I can say that, and I can say like true will work and false will work, but pizza will not work. Right, so this is the second lab with the classes, credit card, all that stuff. So we covered UML, so that's good. And then so we did overloading the constructor, which is where you pass in different arguments, and whatever constructor runs depends on how many arguments they pass in over here. And then we did do a copy constructor, which is makes a deep copy of something. So kind of like in order to do this, we're making another constructor over here, and instead of passing in like these values that you're going to set right here, you're just going to pass in an object of this class. And so then you can say this x equals the copies x, and this y equals the copies y. And yeah, that's how it works. And if I go over here, I can see I made this right here. So I had this fish here, and then I made a copy by just passing in fish there. And then I'm going to see if those two are equal by using the equals method we made. And yeah, looks like they are. Cool. And so let's see, this is talking about the equals method, which we did. It's toString. Main method testing. I mean, yeah, we've been doing that this whole time. And then let's see what else we have. Yeah, so we seem good on that. So let's go to the last lab. This was UML and let's see, object-oriented stuff. Yeah, they talked about the where'd it go? Yeah, right here, the CRC cards, and there's class responsibility collaborators. So these are kind of UML, I guess. So you just have like this card with the class name there and the responsibilities it has. So a student would have like all these different methods or instance. It's like the things it does, and then the collaborators are the classes that interact with it. So yeah. And this looks different from a UML diagram where you're gonna have like the class name and the instance and the methods and all that connected. So it's gonna look like that. Yeah, and then we had to work through this, and like all the verbs become functions, and then all the nouns become objects. Except a whole bunch of um, exceptions to that. And JUnit, of course, which we did. Then there's is it triage? This is just like a way of looking for the errors. Kind of like because it said you could use JUnit for it. Yeah.